We just did our basic differentiation rules as well as our product rule and quotient rule and covered some more trig. But now we want to apply what we've learned with derivatives to word problems. Okay, so anytime we're giving a word problem, a lot of times we're given the position function. That's the original function, say s of t. Sometimes you're going to see x of t as well. All right, in this case, in some of the problems we look at today, v sub naught is our initial velocity and s sub naught is our initial position. Okay, and so we're going to see that in the problem we talk about today. Now when we talk about the velocity function, the velocity is v of t is actually going to be the first derivative of our position function, okay, s prime of t. And then when we talk about acceleration, acceleration is going to be the second derivative of the position function, or you can think of it as the first derivative of the velocity. And then we're going to see average velocity. The average velocity on an interval, closed interval from a to b, is going to be s of a minus s of b over a minus b. So keep this in mind, and I'll keep pulling up the sticky note if we need it as we come across. Okay, so let's look at our first word problem right here. All right. A quarter is dropped from the top of a radio tower, which is 1,362 feet tall. Okay, so that's our initial velocity. Initial position. Okay, it doesn't give us a velocity, but here at the beginning, think about it. If you're just holding it, what is the quarter's velocity? Okay, so what we're going to do is we're going to determine the position and velocity functions for the coin. So the position function, we're going to call it s of t equals negative 16 t squared. Now our velocity at that point, when we're dropping it, when we're just holding it at the top of the tower, is what? Well, it's just 0, so I'm not going to have this term right here. Its initial position is how high up in the air it is, 1,362 feet. Okay, now what did we say about the velocity function? The velocity is the derivative of our position function. So the velocity function equals s prime of t. Now, always define where you got, don't just pull v of t out. You have to say where it comes from. It's the derivative of s of t. Okay, so here when I find the derivative of that, it's negative 32t, and then that is just 0. So it's just negative 32t. Okay, so this is our position function and this is our velocity function. All right, let's look at B. It says determine the average velocity on the interval. Okay, so let's recall that average velocity. It's going to be on this interval from 1 to 2. Okay, s of 1 minus s of 2 over 1 minus 2. And it doesn't really matter what order you do these in, but if I do s of 2 here, the 2 needs to come first here. I know that the denominator is negative 1. And think about this. Our position function is in feet. Well, velocity is basically the position over the time. Okay, so that's what I've done. I've done position over the time. Okay, so s of 1, when I plug 1 into here, and I'm just throwing it into my calculator so I can do this quickly. All right, so 1362 minus 16 is really what it is 1346. All right, minus, okay, plug 2 in there. Is 1298. All right, so 1346 minus 1298 is 48. So 48 over negative 1 is negative 48. Okay, and now if we're actually putting this as units, think about this. This is in feet. And I believe, now I don't know if this means, we'll just assume it's seconds. So this is feet per second. Okay, C. Find the instantaneous velocities at t equals 1 and t equals 2. Instantaneous is when we actually plug into the function and we find v of 1 and v of 2. So v of 1 is negative 32 times 1, and then v of 2 is negative 32 times 2. So this is negative 32, and this is still going to be feet per second. And this is negative 64 feet per second. Part D says find the time required for the coin to reach ground level. All right, well, think about this. Where's the ground located? The ground is located at a distance of 0. Okay, and it's when the position function is 0. And I can go solve this, and you guys know how to solve this, and so I'll let you do that yourself, whether you want to use the calculator or if you want to subtract this over, divide by negative 16 and so forth, and take the square root. And we realize that t is approximately 9.226 seconds. All right, and lastly, number 1, find the velocity of the quarter just before it hits the ground. Okay, so basically the velocity that's at this time right here, just before it hits the ground. And when I do that, what do I end up getting? Negative 295.232 feet per second. So right before it hits the ground, it's going this fast. All right. Now, moving on to number 2. Keep the same idea of the velocity and the position function and so forth. So number 2, a ball is thrown straight down from the top of a 220-foot building with an initial velocity of negative 22 feet per second. All right, from there, what I can do is I can get my position function, s of t, negative 16 t squared. Now they give us the velocity of negative 22 t, and they tell us it's from a 220-foot building. All right, what is its velocity after 3 seconds? Okay, well, what is the velocity function? It's the derivative of the position. So let's go find that. That's negative 32t minus 22. And we want the velocity at 3 seconds. Okay? Always define where you get this from, and you do notation correctly. Just don't plug this in without saying v of 3. Okay? They will dock you later on. And so when I do negative 32 times 3 minus 22, I end up with negative 118, and this is going to be feet per second at 3 seconds. So at 3 seconds, the velocity is at negative 118 feet per second. Okay, now what is its velocity after falling 108 feet? Okay, well here you've got to do a little bit, you have to be careful. This is the height of it from the ground. Okay, the position is the height from the ground. So initially it was 220 feet. I got to minus the 108. All right, and it's 112 feet off the ground. Okay, so now I've got to actually find the time before I can find the velocity. So what I've got to do is I've got to take the position function and I have to set it equal to this right here. All right, so I'm going to take my calculator and I'm going to go to y equals. Okay, I'm going to plug in negative 16x squared minus 22x plus 20 and then 112. Now, I will show you this. Right now my window is -10 to 10. Set your domain. I'm just going to keep my domain like this. But if you use zoom 0, it's supposed to fit to the data, and you should be able to see this. And double check that you put in everything right. Yep. Okay, and I only want this +1 on this side. So second trace, 5 for intersect. All right, 1, 2, 3. This is going to be at t equals 2. At t equals 2 seconds, it'll be 112 feet from the ground. All right, so now I need to find the velocity at 2. All right, so -32 times 2 minus 22 equals -64 minus 22, which is -86 feet per second. So when it has fallen 108 feet, okay, that means when it's 112 feet from the ground, all right, its velocity is -86 feet per second. And we have one last problem. If you want to freeze this and try this on your own, feel free to. Okay, so we're looking at number 3, and I just kind of keep this here just so you can recall everything. The particle moves along the x-axis in such a way that its position at time t is given by, so they gave us the position function and then they gave us the interval. Determine the velocity and acceleration of the particle at time t. Well, velocity, remember, is the derivative of the position function. So let's go find the derivative of that. So it's 12 t to the third minus 48 t squared plus, and I am running out of room, sorry about that, 48 t. All right, now the acceleration function is basically the derivative of the velocity, or you could say the second derivative of the position function. So I'm just taking the derivative of this. This is 36 t squared minus, all right, 48 times 2 is 96, so 96 t, and then I just have plus 48. Okay, moving right along. At what values of t is the particle at rest? Okay, when the particle is at rest is when the velocity function is set equal to 0. All right, so again, we want to use our calculator. We're going to plug in 12x cubed minus 48x squared plus 48x, and I'm putting it all in wrong. So make sure you arrow down. All right, and then put in 0. And again, if you want to say zoom fit, so zoom 0. We want to find where it basically intersects, and it could possibly be intersecting twice here. So we're going to say second trace, 5 for intersect. Okay, one of them's at t equals 0, and then the other one, second trace, 5 for intersect. Let's scroll this way because it could be hitting again. Let's go to the table. If you actually look at the table, it is at 2. I'm not sure why this isn't coming up. If I move closer this way. Okay, I don't know why it doesn't pop up, but if I went to my table like we just saw, it's also at t equals 2. All right. You could probably solve this also by factoring if you would like. If you factor out a 12t, you could also solve it that way. All right, so here we go, part C. At what value of t does the particle change direction? Well, here, when we talk about change direction, it's going to be after it's at rest. So our two times at rest are 0 and 2. All right, now, we want to find, and it says basically, where do they change direction? Where is it going left and where is it going right? If it goes left, the value of the value of this function, our velocity function, will be negative. So v of t is negative when it's going left, and v of t is positive when it's going right. All right, so here we go. Think about if I plug in any number, say -1 into here. I don't actually need to find the value. But if I plug in -1, that's going to be negative. Well, you may need to find the value. So -12. That's going to be -48, and that's going to be -48 as well. So this is going to be negative. I didn't actually have to find the value there. Now, in between here, what about at 1? So I know it's going left to begin with, and then it stops at 1. Let's see if it changes direction. If it changes direction, it's going to be positive. All right, so here, plug in 1. Okay, that's positive 12 minus 48 plus 48. Well, that's going to be a positive 12. So it changes direction here at t equals 0. And let's see at 2. If I plug 2 in, okay, so 12 times 2 cubed, okay, minus 48 times 2 squared, plus 48 times 2. Make sure you're putting it in right. I always forget to arrow down. And we realize that it's actually 0. Whoops, and I didn't mean to put in 2. I meant to put in something after 2. So let's change all these. Second, enter, and we can change all these, say, to 3. Sorry about that. So don't ever plug in any of these values because we know that it equals 0. And therefore, that's positive. So what this means is it's going left, it changes and goes right. It stops here, but then it continues to go right. So there's only one change of direction. One change of direction at x equals 0. And then the last one. What is the velocity when the acceleration is first 0? So first off, what is the acceleration when the acceleration is 0? All right, you can solve this using your calculator and finding where it crosses. So if I plug in 36 x squared minus 96x plus 48, I can say zoom 0 again. All right, second trace, 5 for intersect. Okay, 0.666 repeating, which is 2/3. Okay, I think there's another one. All right, and it's at t equals 2. Let's go back to the question. What is the velocity when the acceleration is first 0? Well, this is when it's first 0. So I want to find that velocity at 2/3. So it just becomes a plug and chug. 36 times 2/3, velocity, so cubed. Okay, minus 48 times 2/3 squared plus 48 times 2/3. All right, and we're just going to leave it like this. Just make sure you've plugged everything in correctly. All right, and it appears to be 21.33 repeating feet per second. So be able to apply what you've learned, know about the position, function, velocity, and acceleration, and average velocity. We're going to come across these word problems a lot this year, and you will get the hang of it. But review over what we've done today, both the basic differentiation as well as the word problem.